Hello, everyone, and welcome to our monthly webinar. So, this is indeed our first webinar of the year 2026. So, I welcome you all to this webinar. So, I'm Abhigyan, and I'll be hosting today's session. So, Ram was originally planned to kick things off, but unfortunately was not keeping well. So, I'll be stepping in on his behalf. So, today we are pleased to have Michael Inden with us. Michael is a well known Java expert with extensive experience in Java performance tuning, memory analysis, and JVM internals. So he has worked with large scale enterprise systems, helping teams diagnose and resolve complex performance and memory related issues in production environments. So, Michael is also the author of several widely read books on Java performance, clean code, and his work is highly regarded within the Java community. So we're excited to have him share his insights with us here today. And please feel free to post your questions in the Q&A section or in the chat. Over to you, Michael.
Yeah, welcome. Thank you for the warm introduction. So let me share my screen. You should be able to see everything. So yeah, welcome to this webinar, Best of Modern Java 21 to 25, my favorites. So it's just a collection of a lot of features that I like the most, but there are, of course, several features. So if you want to try out some of the examples, you are free to download this GitHub project. I show what is included later on. You find there some examples, some exercises, and so on. And of course, all of these slides. So just let's get started. Who am I? I'm Michael, and I studied computer science a long time ago. I started as a software engineer and software architect, getting promoted to team lead and worked as the CTO, later on as head of development. Currently, I'm an independent software consultant, and yeah, as you see, I wrote a few books on Java and even on Python, and I like to share my knowledge and give workshops, webinars, and so on. So, what is the agenda for today? We will look at the top 10 of my favorite features from Java 21 to 25. But before, let me give you a brief introduction on my all-time favorites, which lay the foundation. They are all included in Java 17. So switch expressions, text blocks, records, and pattern matching. They are so important that we should have a first brief look at them. And later on, I just selected 10 of the new features. I ordered them chronologically because, yeah, there is no real order. What you can say, okay, structure concurrency is my favorite, and another one says, okay, Markdown is my absolute favorite. They are all important and they are all really cool. You see that structure concurrency is specially marked, and you see there is a preview. Normally, I would not say I like to introduce preview features, but structure concurrency is different. It's so important and such a big step forward in making multi-threading in Java understandable and uh, much easier, so that you should get an idea what will happen in Java 26 and Java 27 when it hopefully in Java 27 get finalized. So then let's get started with the all-time favorites. Four of them, but four which are really important to make your code more clear, concise, and robust. So the first is switch expressions. If we look back, when Java was created, you have to make the language attractive to C++ programmers. And so, yeah, we borrow some things from the old switch statement from C. But to be honest, there are lot of things which are not the best, like the break and the fall through, which lead to careless mistakes. And yeah, the default is perhaps not at the right place, and it's not that readable. And now we get switch expressions. They are far more readable and understandable. You can just provide a comma separated list of values. The mapping is easier. You see there is no break because there is no fall through. So there are no careless mistakes when there is a fall through. And the best thing is you can even return a value, which makes your code really, really short and concise. And as I mentioned in the past, if you have a default and you forget the break, then you have some fall throughs, perhaps even several times, which can be very confusing. Right now, it's still a good case or good practice to move the default to the last position, so that's a bit more clear. But this is no error any longer, because if you have this default in between, then it's just executed, and there are no strange things happen. So, but please, yeah, use default as the last line. One thing which is long awaited, and we got this with Java 17, it is text blocks. This feature allows us to specify multi-line strings, and that we do not have to escape all the double quotes, and that we do not have to provide this \n for line separation. You get a clear, concise view. As you see, if you have to provide a small snippet of JSON or XML, it's so easy to do this with text blocks. As a real world example, imagine you have something like a word puzzle where you have to find several words. Okay, these are in German, like computer, Löwe, and so on. And you have to find them in this mix out of randomly selected jars. We see here elephants, so for example. But what is the idea here? You can provide a readable start section describing this HTML and an end section. And then the methods like create table produce snippets which use these text blocks too. But perhaps the best enhancement in Java 17 is records. Why? Because they allow us to define data classes, data holder or data transfer objects with one line of code. You just write something like record, you pass in some parameters, and what you really get is this. You can use this Java P tool included in the JDK. This allows to decompile the Java class. And what you see is, if you write this line, you get something which is a final class extending Java lang record, providing accessor methods, providing toString, hash code, equals everything, which sometimes is a careless mistake that you omit defining this stuff. And if you look back, if you want to create a class which is equivalent to this, you have to provide the attributes, a constructor, you have to provide equals, hash code, and you see there's even no room, and we have to omit the accessor method. So even with two attributes, it's just one page and compared to one line. So if you imagine you want to add 2 or 3 more attributes, it's getting even worse. So it's really cool to have this feature, but it's getting even better, because in the past you sometimes wanted to return multiple values out of a method. So this was not that easy, because yeah, you just are allowed to return one value, what you can do is define your own data class, but then you end up defining something like this. And it's really a lot nicer to just write a record, and then you want to provide an integer code and then string information on the code and a list of values, or let's say you have two strings and a value that you want to return. And even sometimes you have to access maps in a not that easy way that you have string or integer keys. You have compound keys consisting of, let's say, in this case, a string and an integer, or even two strings or an integer. It's possible. So you just defined your record, and then it's really easy because it's already implementing equals hashcode to string, and they are all compliant to the contracts. So that's really important and easy. And if you just need something more to get convinced that records are really cool, imagine that you have to write something like a pair, and everyone wrote his own pair in the past. So it's really not that easy. And if you want to do this with generics, it can be annoying. And if you want to use it with even primitive values, it's nearly impossible. So now you just write your int pair using primitive types, or the string int pair using this combination or this generic combination. Or imagine you are working for a pizza delivery service and you have to model the top 3 favorites of the week or the month. Yeah, let's define this record top 3 favorites. Now it's really easy, and you don't have not have to think about all the nitty-gritty details. Or you have something like calculation, you have something which needs to return the minimum, maximum, and an average and the count. Yeah, let's define a simple record. It's really just a little effort. It's really practical. It's generating all the necessary stuff, and it's even possible to implement interfaces and a lot of more things. But for now, that's enough to get an understanding of records. We move over to pattern matching and instance of. In the old days, before Java 16 to be precise, we sometimes find something like an instance of check in our program. And of course, if this instance of check is successful, the compiler and we know that this object is a person. So why do we have to write this single line with this ugly cast? And if you have multiple instance of checks, then you have multiple casts, and it's getting even uglier. Now with Java 16, and of course included in the 17 long-term support release, you just write object instance of person. Person, you have something like this explaining variable where this, if object isn't person, then it's already filled in into this person. And it's getting even better. You are allowed to check pattern match if this is a string, and then you can even supply something like guard conditions, like checking the length or checking if the string contains a version marker or something like this. So these are the foundations for modern Java, and now we move over to my top 10. Number 1, record patterns. As we just saw, we get this pattern matching, for instance, of in Java 16. And let's think of just an easy point record, and we want to print out some information about the coordinates. So we can use this nicer syntax, but of course we have to access the 2 coordinate values to print them out. This is better than in the past. We can omit the cast, but yeah, we have this code to access the attributes. So to make things easier, we are now allowed to do something which is called decomposition. So we, instead of writing point point, we can write something similar to a record. This is or record definition. So this is why this is called record pattern. You write instance of point, and then this is more or less the definition of the record. And then what happens if this is a point, then these two informations or these values are directly inserted here. So you are not forced to name them as they are named in the record, but it's a good idea to keep them as similar as possible. So a bad idea is to switch these values, or otherwise your colleagues will be really confused. Let's do it a bit more practical and see what we can do. The good thing is record patterns can be nested and they can be deeply nested. So what perhaps in the first example it's not that obvious. It's a data navigation possibility. We have this record. We know already we have an enum which provides some colors. Then we define a colored point, and then we define something like a rectangle or a gradient line defined by two colored points. And we can just decompose this using all these subcomponents. And we are not forced to decompose into the latest component, but we can do if we want to. So what we need here is just the color. Okay, we decompose just the first point. Where do we see the best parts of record patterns? Where do they show their strengths? In the past, in legacy code, if you have to check a lot of things, then things can get really cool using record patterns. Imagine we have something like a flight reservation consisting of a person, a phone number, and two city information. And what we want to do is we want to perform some checks. If we want to check the age and the destination and the language code, then conventionally we do something like a lot of if checks, and we have to check if there is a person information. Then we have to retrieve the birthday. Then we have to look at the reservation destination. Then we have to move. What you see is we are moving in the object graph. And we need all these consistency checks that we ensure that we do not access null values. And if you look at this code and I ask you what is this code doing and what are the most relevant lines here, it's not that easy to spot. But to be honest, there are just a few lines which are relevant. These are these with the if. The other lines are just navigation in the object graph and ensuring that the components of the object graph are provided. So this is important stuff here. And what we can do is what is this? Paul's quizzes?
It's a poll, Michael, that we are running here. Yep. You can just
Okay.
close that window here.
Okay. If you look at the code, if we just use record patterns, then you see, if you look at this code, we are just forced to write the important lines. Of course, it's first not that easy to get used to the record patterns. But we will see later on that we can make it much more clearer. And you have to get used to this. But what you see is that you decompose the flight reservation into these components, and only person and the city component are of interest. So if you follow good programming practice, you perhaps can omit this if birthday not null and language code not null, because you should ensure that a person is a valid person and has birthday set, and perhaps that the language code is also set. So we can even get rid of this line in good code. The cool thing is we saw all these navigation things, they are not necessary any longer. If you use this record pattern decomposition, then this ensures that there is a valid person and there is a valid city, so you can access the attributes and the members. Number two, pattern matching and switch. In the past, yeah, we are allowed to use this pattern matching with instance of, but we are not allowed to use this with switch. This is changing with Java 21, and we first got something like we can provide a guard condition, but we have to be careful because in the switch you have several possibilities to specify conditions. What you see here is that the string S is more general than this asking for the length. So you have to be careful to not switching this. If you use the string up front or before this other, then you will never reach the second pattern. So this is shown here. This is detected by the IDEs. So make sure that you use the right order, but perhaps for your if you want to look this up, it's called dominance check. And in the past, there are problems in Java that it's not always detected, but right now everything works fine. So we have then another example. We have this record with three position attributes, and we have this color. And I'm just showing what you can do. You can use this normal possibility to ask. You can use this question if this set coordinate is 0, or you can also use this record pattern. There are now a lot of possibilities, and yeah. Now we are coming to virtual threads. One of my favorite features if you have to use multi-threading and you have a lot of I/O blocking calls, then it's a good idea to use virtual threads. What is the key idea? Virtual threads are really lightweight. They are like normal threads, but they are not directly mapped to operating system threads. The core idea is that if you have several threads, they perhaps are running, they are waiting for something, they are in runnable state, they are blocked. And if you look at them, it is possible to have all the active phases where they are running performed by just one thread. So the key idea is if you have something like a typical application, you see marshalling stuff, which is done by the thread, and then if you have network transmission and you have server processing and you're waiting for the answer and you're doing all this in one thread, this thread is blocked for hundreds of milliseconds, and then it's returning the value and it's doing this unmarshalling stuff, which is normally nanoseconds. And this figure is not quite correct from the dimensions. This is more or less one line if you just want to compare nanoseconds to milliseconds. This millisecond area is far bigger. So if you have this in mind and you look back here, and then you see, okay, this is why it's a good idea to map multiple virtual threads to one real um, operating system threads. And the cool stuff is that they managed to have the same API. So virtual threads are normal threads from the API. So if we look back, if we do something like or simulating a lot of work, we are just sleeping here and we are using a normal cache thread pool. Depending on your machine, you are allowed to run perhaps 5,000, 10,000, perhaps 15,000 threads in parallel. But it's impossible to run, let's say, 100,000 or 500,000 or a million threads in parallel. Um, but if you imagine this marshalling stuff and unmarshalling stuff is just nanoseconds and the waiting time is so much longer, then it may be a good idea to have the possibility. And just to try it out, you have just to change one line or just one statement. This uh, new cache thread pool executor is using a pool of threads, OS threads. And now you want to switch this, you just change this one statement and you are now allowed to use this virtual threads. And now you can even use 10 millions. And just to get an idea, and I provided an example project. So if you use something like these normal platform threads, depending on your machine, you get stuck, let's say, around 12,000 threads. And then you get something like an out of memory. It's not possible to start platform threads any longer. What you can do, of course, is building your own thread pool, and then you're just doing things in bulks of 10,000 if you're doing a fixed thread pool of 10,000. If you switch to virtual threads, you see it scales very well. It's nearly just this time, which is simulating this I/O. So this is really cool. And even if you are enlarging the number, then you are nearly having this performance. Number four, structured concurrency, as I mentioned, is still a preview feature, but it's really worth having an idea. It got introduced in Java 21. It was a real cool API. It got some changes in Java 25. So, what is the idea? Starting threads in Java is easy. Doing multi-threading in Java the old way is really hard because you have to know about Java memory model, you have to know about synchronization, you have to know about happens before order, and a lot of things. And if you like to spawn multiple threads and combine them, and you will not do this on your own. This is normally horrible to ensure that everything is working perfectly. So we um, look at an example just doing two strings in parallel, but first we start doing the things synchronously. Like say we want to find the user based on a user ID, and we want to fetch the orders, and then we generate a response. What is obvious, this code works, and let's say this takes 2 seconds and this takes 3 seconds, so we have to wait 3 seconds. And then, of course, perhaps someone says, okay, perhaps we can run this in parallel, and this would be faster. Let's try this using a classical executor service. We switch this to the new cache set pool, submit these actions, and we're waiting for the results, and then we create the response. If everything is good, the happy path is fine. But if it comes to error handling, if you want to quit asking for the orders, if user future or this find user provided or raised an exception, then things get complicated. So this is not the best. And using structured concurrency, you get something which is called structured task scope. So what you get is in your block of code created by the structured task scope, you are now sure that at the end of this block, no more thread is running. And the structured task scope knows about this thread it started. And if one of those raises an exception, the other one gets interrupted. So now we benefit from performing things in parallel and having something like a easier to follow mental model. So we are sure these threads are done here. Um, I added this command. If you use this shortcut open, then you get something which is joining the results and awaits all of the results. If one of those produces something like an exception, then the other is stopped. So this is what you normally want. But of course, there's also the possibility to have this any successful result or so, which is yeah, the idea. I invoke a lot of tasks, and I really do not need all of the results. I just need one result. Let's say I'm doing something like a price search, and or something like a search in the internet, and the first one is good enough. Then that's fine. Or let's say we want to try to connect to our wireless, and we are trying out some of the connections, and the first one wins, hopefully the fastest one. And this is really easy just to implement because we are just using another joiner. And again, at the end, we know that all these threads performing the single retrievals, they are done. And since we know that we just get one result, we can now say, okay, we get one network connection because if 5G is successful, the others get interrupted, and we can just continue with the result of this method. This is really cool. And it's getting even better. Structured concurrency can be nested. So you can create subtasks which use other scopes, and they use scopes inside. So let's look at an example. Imagine that we want to book a trip, and of course, what we need is we need somewhere to stay. So we need one hotel, and perhaps we need a selection of possible car rentals. So this is why we use this open, which is saying I'm waiting for all to be successful. If we do not have a hotel or if we do not have a car, we can't do this trip. So um, this is really easy. And we are just calling normal Java methods. And these Java methods, again, open different structured task scope performing their subtask. So what we are doing is in this find totals, we are saying, okay, we want to ask different providers for yeah, some suggestion, and then we are using join, and then we're getting one of these results. But perhaps at this moment, perhaps you think about, okay, it would be nice if we do not just get one, but perhaps a selection of two or three. And this is also possible. You can build up your own joiners, and this is really not that hard. It's about 20 lines of code. So you can build your own joiners. Let's say, let's call him, or let's call it first and successful. Um, and then we can just get the first successful results, in this case, the first two. Number five, something smaller but really, really helpful, unnamed variables and patterns. When we are using record patterns, we notice something. We saw when I presented record patterns, we can decompose this. And if we just need one component, then we can decompose this, but we have to provide all the other components too. They are not of interest at all. So the same applies if we have something like a lambda expression, and on the right side of the lambda, we do not use one of the parameters from the left side. Or sometimes we have exception handling and we do just some logging and we are not using the information provided by this exception. So these are more or less unused. So would be cool to have the possibility to indicate this. With this JEP, we get the possibility we can use simple unnamed variables, just using an underscore, marking them as unused. We can have the case unnamed pattern variable. We have one identifier, one part of the pattern to be marked as yeah, unused, and we can even use the complete pattern and replace it with a single underscore. Let's go through the examples. We just saw this lambda expression. Lambda expression is far easier. Now it's obvious that this is unused. Let's imagine we have an interface and we are not using the last coordinate. So it's far easier what is unused and what is used. But the real strength comes when you are combine this with record patterns. So in the case of this color, we can mark this color as unused because we are just accessing the elements of the point. And of course, everything which is shown here, for instance, of is also usable in case. And even better, if I have something like the color marked as unused, then why I have to specify a type for a variable which is unused. So this can get even better and shorter. I do not have to provide all that stuff. I just write int x underline underline, and now it's clear that we use just this part of our record pattern. And it's not possible to ask for instance of underline because it's just a keyword, it's not a type. and of course you can't decompose a record. And I promised you that the initially shown bigger record pattern, which was a bit unreadable at first, will become far more readable. Here is a slightly different example, but it's nearly the same. You have a journey pattern. The person, you indicate that the two attributes are irrelevant. You see the travel information, and it's obvious that the original city is not of importance. So this it's getting really nice, and you immediately see which parts of the journey are of interest and which are unused. Number 6, launch multiple file source code programs. This is a feature that goes back to Java 11. There you get something which is called single file source code programs or direct compilation. What is the key idea? You have a single file, and instead of doing Java-C and Java, you can just create or just execute this Java file directly. What is performed under the hood is, of course, it gets compiled and then it gets directly executed. Why is this nice? Because you can build your own smaller scripts, or you can build your own simple command line tools just using Java, and you do not have to learn all the nitty-gritty details of the operation system shell scripts. And with this JEP, it's possible not just only to launch one Java file, but to just split up Java files into multiple files like this application, and it's just getting a helper class just for demonstration purposes. If you call this or execute this Java main app, then this gets loaded. It's getting detected that there's a helper class which has to be loaded, compiled, and then it's executed. And of course, you can even use a second helper class, and this is also performed like this. You're loading this. It's detected that you first need the string helper, that you need this helper. So you can split up your programs into multiple classes as needed using more object-oriented design, and you're not forced to put everything in one file and keep it there. This is a nice addition. Another one is Markdown commands. When Java got invented, it was very reasonable that HTML was chosen to document Java, but right now Markdown is far more common, and now it's possible to use Markdown. You have these 3 slashes. You still have the Java doc text like param and return, but what gets easier is how to switch to source code and how to use links. The good thing is that your IDEs are aware of this new feature, and if you hover over, let's say, your max method, you get directly the representation. You see this is this int, you see the link here, you see the params and returns. And if you want to play around with, let's say, bold italics and so on, you are free to do this. You have the backticks for typewriter font. And the best thing is, in the past, it was so hard to include multi-line source code, and now you are just using 3 backticks, and this gets nicely formatted, and yeah, this is far easier than in the past. And you can even specify bullet point lists. You can specify numbered lists. You are not forced to use continuous numbering. Markdown tools just auto-correct the numbers, but to do yourself a favor, number them correctly. You can specify simple tables. So this is a nice, cool feature. Number 8, stream gatherers. In the past, sometimes you may have the wish that you can define your own intermediate operations, or you have the wish that something like an intermediate operation like distinct by and others exists. So what is the idea? We have this stream of values. We want to get only those distinct by this condition. Yeah, this is not provided, and there are a lot of ideas, but if we get all of the desired methods into our stream API, this would be even become overloaded with functionality. So the idea was to include a mechanism which allows us to define our own intermediate operations in an easy way. Let's say another example for a desirable functionality is something like window fixed. What is the idea? Your stream is subdivided into parts of size 4, and you can imagine any size here. So let's say you have to group your stream into boxes of 4, 5, 10 elements, and you want to perform operation on these elements. Would be cool if there's something like a window fixed. But of course, as I mentioned, if all these proposals would have been added to the Stream API, it's yeah, would be more complicated and would be overloaded. So what is the solution? We get a new method which is called gather, and you can provide a gatherer. And yeah, this is a way how to introduce new user-defined intermediate operations. And because it's nice to have some predefined gatherers at hand, we get something like window fixed, window sliding, fold and scan, and we take a look at those. So if we want to create something like window fixed, this is an infinite stream. We want to have windows of size 4. We want to limit this to 3. You see, it's working like expected. If your stream has less data, then yeah, it's the last one may just contain 1 or 2 elements. What is the difference to window sliding? Window fixed is going blockwise. Window sliding is like yeah, moving one by one over the stream of data. This can be interesting to detect jumps. If you think of temperature data or stock market prices and you are going over these, then you may detect, oh, there's a temperature jump, or there's a jump in the stock prices. Yeah, this is just stepping one by one. This is the idea of window sliding. There's another operation which is fold. This uses all the values based on a starting value and a calculation expression. It's calculating this 1 multiplied by 10, multiplied by 20, and so on. And that's all. And sometimes, yeah, okay, it's even possible to change the type. What we want to do here is switching to a string, and we want to repeat the number according to its value. So we have 1 1, 2 2, 3 3, and so on. But what I wanted to say is there's also the possibility of using scan, which allows us to get all the results, so that we see, okay, for the 1 1, and then we get nearly all the intermediate results, so that you can see the operations performed element by element. These examples are a bit artificial, but sometimes the scan can be really, really helpful. So there's an optimization technique which is called prefix sums. This allows to sum up all the values and then perform calculations very fast. So if you imagine you have something like expenses or other things, and you want to just know, what are the expenses in this period of time. So you normally have to always add up the values in between. If you do something like prefix sums, you just calculate the total once, and then you just can ask, and you just have to ask for the value, let's say here, and then you subtract another value, and then you're getting the answer. Instead of summing up all the values in between, you're getting the answer with incredibly fast. So the same can be achieved if you want to do something like a window fix, so that you have the expenses accumulated by week and so on. So then you see, okay, we have all these expenses accumulated. There's another special thing in the stream gatherers. There's a new method called map concurrent. This is nearly just a concurrent version of the traditional map. What is cool about map concurrent? Map concurrent uses virtual threads. So if you look at the base, we have something like 500 values to process. We ask to use a parallel stream, and let's assume that this lookup takes around 1 second. Then this gets processed by perhaps 10 or something like this independent threads. This depends on the fork join pool size, but it's let's say around 10, 15 or something like this. So if we switch to map concurrent, we are free to specify any number of virtual threads that we want to perform these actions. So we can just change from there to there, and we reduce this to 2 seconds. And even if we use 500 here, then we can reduce the time just to 1 second. So this is really, really cool. Map concurrent is the faster alternative to the map operation. Number 9, flexible constructor bodies. In the past, we had some language restriction concerning constructors. So let's assume we have the class positive big integer and we have the first try, and what we want to achieve is that the passed value should not be negative. But of course we are forced to call the superconstructor first. This is not really elegant if we perform the check after we constructed the base class, because this work is not needed if this condition is not met. So if you imagine legacy code where perhaps in the constructor are strange things or happening strange things like perhaps database accesses or something like this, it would be really ugly that we do all this stuff and then throw everything away. A workaround in Java was to create something like a static verification method. You can wrap this around your parameter, and then you can prevent calling the superconstructor because this throws an exception. This is okay if you have one or two parameters. If you have more parameters, this becomes clumsy and not so nice. With Java 25, it's far easier. You can move your check and then later on call super. This is really nice. So this feels absolutely natural that you can perform checks before calling super. Of course, you can't access attributes from your class, but you can do nearly everything what you want to do, like checking the parameters passed to the constructor. Why is this nice? If you think of records, then let's say we have a record with two coordinates and one with three coordinates, and we are performing always the same things, and it's really easy to make mistakes, and we are doing all the stuff 2 times, 3 times, and perhaps it would be nicer to do the processing of the individual values upfront and then just calling the standard constructor, and we can just define a helper method here. So it's more readable and you're not performing all the work several times. But there's something which can be really annoying. If you have a base class and you are calling a non-private method in your constructor, strange things can happen. Let's assume this simple base class, we have an int value, we assign this, and then we perform this log values, and we get something we print out to the console. Everything fine, but when we then create a base class with this separate attribute, and we are calling our superconstructor and then initializing our subclass info, strange things happen. What we are doing, we are creating the subclass with 42 and surprise. What we expect log values to print out is 42 and surprise. But we got 42 and null. And the problem is that when we are constructing this subclass, we are getting this 42, we are calling the base class, we are assigning this value, we are logging values, but this log values calls this superlog values, and then it's calling this subclass info, but this is not set because we haven't executed this line. So this is really ugly, and even final fields are not initialized at the right time. And flexible constructor bodies allow that you perform parameter checks and even access your own attributes before calling super. So you can access your own elements, so you can assign this, and then everything works as expected. A better idea is not to call protected methods or public methods in the constructor using abstract factory or other ways to construct your classes. Last one, number 10, compact source files and instance main methods. When we look back, or if you look back and you remember when you learned Java, it is not that easy, and you have to get an idea why I have to write this public class and why I do have to write this static void, and then yeah, passing the string arguments. If you look at Python, it's just a one-liner. And if you're working as a trainer, or you have junior developers, or you have people to get used to Java, and when you explain this code, you say, okay, you do not have to know what class means, what static means, what these braces mean. It's just this line. This is really not that nice. And the guys at Oracle wanted to make it easier to learn Java. If we look back the past, we have this longer method. Then we have the possibility to leave the modifiers away. We have to the possibility to leave out the parameters. And if we are here, then it's a good question why we have to note the surrounding class. So we are allowed to omit the class. So this is now the shortest hello world in Java, which is nearly as short as in Python. What is even better, before you want to understand what class and other things are, you want to do something like creating simple methods, defining variables, and you are allowed to do something like this, creating your own methods and calling them. This is perfectly fine in Java. And even better, if you want to interact with the console, this is really not that nice in Java and older Java versions. And what beginners like to do is like asking questions like, what is your name and how old are you? And then print out in 10 years you are 65 or something like this. Now you got a new class, IO. We get print and a read method, which allows us to read in values from the console. So it's far easier to start small, and then if you need things, you have the possibility to grow your classes. Let's just briefly look at what is coming in Java 26, which will be released mid of March. You see 10 JEPs are finalized. Perhaps the most important are you get support for HTTP 3, which is the most current HTTP version. And two more things. We get another preview of structured concurrency. There's just a small change. You get the possibility to react on timeouts in a different way, and lazy constants, which allow to define nearly constant values. And let me come to my conclusion. What is really cool, we now got this reliable 6 months release cadence. We get uh, long-term support release versions every 2 years. As you see, Java is getting easier and more attractive. We have some nice improvements like switch records and so on. Pattern matching is nice. Record patterns are really cool. Virtual threads and structured concurrency are a game changer when it comes to multi-threading. And yeah, Java 25 just got released and it's really nice to use it. If you want to look at the negative side, yeah, the releases were on time, but sometimes they just include small things, a lot of preview features, and especially this is true for Java 25 and Java 21. From my perspective, I would like to contain long-term support releases, only a few, nearly none preview features so that you can use all that stuff that you get at that time. So this is sometimes a bit annoying. Yeah, but it's always good to try something out. If you want to try these things out, you have this link and you find um, Maven and Gradle project there. There you have some examples about the all-time favorite. You have final features in Java 21. You have all the stuff about Java 25, the gatherers, map concurrent example. Um, you have some window examples there, and as I mentioned, it's always good to try things out. So you find for exercises with sample solutions, playing around with flexible constructor bodies, stream gatherers, and structured concurrency. And if you need some more help, then there's a book. Yeah, it's currently in preparation. And if you speak German, then yeah, there's the German version already published. And if you like to solve some programming challenges, yeah, try out my Java challenges book. And now, many thanks for your audience. I hope I could show you that Java is really undergoing yeah, a lot of good things, that it's getting more modern, more enjoyable to work with Java 25. Yeah, any questions?
Okay, so thank you, Michael, for a truly insightful and engaging session. We really appreciate you sharing your experience and perspective on Java 25 with us today. And thank you to all our attendees for joining us and for your active participation throughout the session. We have been conducting polls and we have been getting good responses. So thank you everyone for that. And we hope you found it valuable. And we look forward to seeing you in our next webinar, which is analyzing application logs using AI. So until then, we have a great day, and thank you once again for being with us.
Thanks a lot. And if you have any questions later on, there's my email address provided in the slides. Feel free to reach out to me.
Thank you so much, Michael. Thank you, everyone.
Thanks. Bye bye.
Bye.